Yeah. Say hello. Okay, but other people are watching it, so it doesn't really matter. Okay, here we go. All right, so we just finished our bear hunt. And the important thing that we discussed about bear hunt is that getting a proper sample is crucial when you're going to make inferences about the population. So we can see here that our goal in sampling is to make sure that we correctly represent the population and that our sample does not suffer from any type of bias, of which we had visual bias on our bear hunt. Okay. So therefore, we're going to be talking about a few things of sample versus population, or sample versus population, and the different sampling methods. Okay. Now, before we start that, it's important for you to understand that samples have different letters than populations. Okay, samples have different letters than the population. A sample, which is just your little bitty sample that you have, uses Latin letters. Okay? Latin letters are the letters we use every day in our writing, just the regular old plain printing letters. Okay? Population values are represented with Greek letters. You know, like you're thinking of Greek people, or sororities, delta, whatever. Okay, delta, delta, delta. Okay, so anyway, populations use the Greek letters. So if you're ever reading a formula and you see a plain old letter, that means they're talking about the statistic, the plain old sample. Okay, and by the way, I said statistic. Sample numbers are called statistics. So I guess in essence, this class is about numbers about your samples that you take, whereas populations values are called parameters. So if somebody somewhere is all divine and knows that 30% of the United States likes the color green, okay, that's called a parameter because it's about the whole population. Oh, well, on our bears, when we knew that number, when we had the luxury of knowing that value for the whole population of bears, those were called parameters. And then what we got in our samples were statistics. Okay. All right, so here's a couple of examples. The means are the letter that represents is an X with a little bar over it if it's just from your sample. However, if it was done for the population, if it's an average for the entire population, then you use the Greek letter mu, it's the lowercase mu, which looks like a cursive U. Okay, looks like a cursive U. All right, standard deviation, which is a topic that you still have yet to understand what that means. It's a measure of spread. It's just the plain old letter S, a lowercase s, if it's about your sample. If it's about just your 10 numbers, then that's a plain S. However, if it's about the entire population of 100 rectangles and the spread of their areas, it's a lowercase sigma, which looks like a cursive O. So it's Greek. Okay. Now, not that I'm expecting you to, totally just boom, have those memorized. The point is that statistics that are based off the samples have different looking letters than parameters. Okay? All right. So that's something you should pay attention to when you read through things, because they mean something depending on what they look like. All right. Next thing, the importance of randomness. And so you did your random rectangle activity last night, so I'm going to have you get that out. And we're going to discuss it and then fill in the analyzation on the back page. Okay, so I have some values up here that I did when I did the rectangle. I picked 5 rectangles that I thought best represented my data. Okay? And when I averaged it, I got 9.6. So I want to get some of your answers. So I'm going to start with Sophia. What'd you get here? 14.2. And then Bethany? 6.8. TJ? Okay. 10.6. And Ben? 10.2. Okay. There are no wrong answers on this page. You're going to give me what you came up with, and we're just going to look at it and find some interesting things about it. Here's the interesting thing about all these numbers. 4 out of the 5 of them are higher than the actual average. Okay? And let me tell you why. When you see this page of rectangles, your eye, just by nature of your brain and the area of this, is drawn to the larger shapes. And you don't recognize that there really are a lot of single ones sprinkled in here. And those ones, areas of ones, is going to pull that average down. So all you people that picked, everybody but Bethany, overestimated the average because your eye was naturally drawn to the larger shapes. And that was what you did in your best judgment. So, should we rely on our judgment? Never. We never should rely on our judgment when you pick things. Because whether you meant to or not, you always have some sort of bias in there. Or, not always, but very likely there's some kind of bias, whether you mean to or not. Okay. So there's that. Let's do simple random sample. Okay, so real quickly, remember this one? You just numbered them 1 to 100, and then you use the random number generator to pick your rectangles. So let's see what we got. Aaron, what you got?
6.
Okay, and then Darian. Okay, and Lauren. 3.8. Okay, and then what? Caroline? 5. Okay. Now, I got 11.8, which was real high. Actually, all day, I will tell you, all day long, the values on these have been lower than the actual, or like just around the actual or lower. Mine's kind of been the only weird one all day. Okay, so let me tell you why that is the case. Simple random sample is actually a pretty good method. I mean, it's generally going to do a good job of eliminating your visual bias. Okay? But you know what the deal is that a higher number of rectangles are really small. So technically, there's a higher probability of getting a small rectangle, which is bringing down your average. Okay? So that's why when you just pick 5 and the smaller ones had a higher chance of being picked, just like overall, then that's why these numbers all day have been on the low side. All right, next, cluster random sample. Okay, this one, let's think about what that was. What happened on that page? The person who wrote the activity did what? Just drew a line. Did the person sort them by shape yet? No. They're all randomly on the page, then they are sorted, or they just have a line. Okay. And then you did a random number generator and picked a cluster, and then you picked 5 within that cluster. So, let's see what we got here. Let's do this group here. Katie?
4.
Okay. Sydney? 10. Dakota?
2.6.
Okay, 2.6. Tyson? 8.4. And Luke? Wait. Luke? Okay.
6.
Oh, yeah. Does it matter what yours is? Did you really actually do it? Okay, cool. All right. 5.4. And Matthew?
5.
And then Chris?
2.8.
2.8. Okay. interesting. Okay, I think overall, I've not really had a class that had as many lower ones. You know, the point is that in my experience, the values in this method of sampling have been quite varied. Meaning, look at the spread. We go from a 10 to a 2.6. And so that's a lot more spread out than these ones here, which were clustered 3.8 to, now see that is a weird one. Okay, and then these weren't too bad. Well, I don't know. You kind of got that. So that, oh wait, but that was our judgment, and that's all messed up anyway. Okay, so I think perhaps clustering was not the best method here because they've all class periods have been quite varied. Okay, all right, let's do stratified. Stratified had put them into size groupings, right? Homogeneous groups by size, so that then you picked what? One of each size. So the goal is that now you're kind of making sure that you're getting one of each type. So that's what stratified did. And so let's see what those numbers were, Richie. 6 and Nina. What? 8. Okay. Jeff? 8.6. Okay. And then Dylan? 8.5. And then look at mine, 7. Okay, what do you have to say about all those? Yeah. All day long. I mean, it's just, I don't know.
You mean you take one from each of the 5?
Correct. You had one of the smallest, one of the next one of the middle, and then one of the biggest. So you had one kind of in each size category.
I took 5 from the first one.
Oh, okay. So, and then you got a weird number, didn't you?
I got 1.
Correct. Okay. So then yours wasn't this process. Yours was something different. Okay. So what we see is that this one appeared to be a better predictor, and these are all around the correct answer. So since size was such a significant factor in determining the area of a shape, and that's what we were determining here, size was a good way to stratify because that made sure that you were getting a good sample of the spread of the sizes. Okay, systematic. Okay, that was the one where you picked a random one and then you did every 20th. Okay, so let's get the rest of these here. So, Sarah, what you got? 10.2. Parker.
5.8.
Okay. Kate, no, Shania. 10. Billy.
6.6.
Okay. Dalton.
9.4.
And Maddie.
11.
Okay. And then Allie. 8 point what? 4. Okay. I mean, I don't know. They're not like 1 or 2.6 and 10, but you know. So we're still having some variability here. Okay, maybe a little better. Anyway, okay. So the real answer is, drum roll, please. Okay. Yeah. Actually, there's a debate on the real answer. Okay. Suspense. Okay. I can't say the real answer is because I don't know. I averaged all 100 and I got 7.49. However, my teacher friend averaged all 100 and she got 7.42, which actually brings up an interesting point. What happened when we both attempted to average all 100 and take a census?
Someone messed up.
Yeah, somebody messed up, maybe even both of us. So accuracy came into, play when we attempted to do all of them, but I think it's somewhere around there. Somewhere in the 7.4 range, 7.5 range. So now let's revisit. Which one then looked probably to be the best? Okay, stratifying. Yeah, stratifying. Okay, very good. So turn to your last page and let's do the analysis of what we just talked about. Okay, simple random sample. Here's what happens on this. That's where you like put everything in a big bag and you like give everything a unique number, and so then you're drawing. Everything has an equal chance of being chosen. So that's what we want to put here. You have to devise a method so that all items have an equal chance of being chosen. Okay. Now, frequently you will be asked to describe a randomization method that is a simple random sample. Let me just give you a quick little fast and easy description. Sometimes you can get real tricky and some things are right and some things aren't right. Here's the fastest and easiest way to describe in writing a simple random sample. Put all items in a big bag, mix well, and then choose your sample. Or I guess maybe choose kind of sounds like you're personally picking. Draw out your sample items. Okay. So what employs the randomness component in here in this description? Okay, you can't see, but it's actually mixing well. You know, then you didn't go put your tickets to the lottery on the bottom so that when you stick your hand in there, you're going to reach down there and grab the ones on the bottom, right? Because you have a better chance of getting one of yours, and so on. Okay? You mixed it well, so you don't have any clue where your lottery tickets are in the big bag. Advantage is that it is free from bias. You had no input into what was chosen. All equal chance of being chosen. Disadvantage is that it is often high in money to do that. It's a costly event when you have a lot of things. Also, sometimes it is difficult to have access to all the items. If I want to put everybody in the United States' phone number in a big bag and then draw whatever out of it, that's hard to do. Okay, that's a difficult thing to have access to, so I don't think I could do a simple random sample of that. Okay, good. Next, cluster random sample. Okay, so think in your brain what that was. That was took the page that was randomized, made it into strips. And then you pulled out, or you randomly chose a cluster. Okay, so let's get started here. We first say divide the items into groups or clusters. Okay. And then you randomly choose technically, it doesn't have to be just one cluster that you choose. You could choose one or more, a few clusters. Okay? Now, on our rectangle activity, we only had 5 clusters, so that would have been kind of weird if we picked more than one cluster. But if I clustered Aledo High School by first period, then there's like 60 classes. So then I would probably want to pick about 3 clusters or or maybe even a little more, okay? Now, I want to change this on next year's instructions because there's a bit of confusion in the way that your cluster sample was taken. Technically, y'all chose 5 on your one cluster. That's employing a simple random sample of your cluster. So you like clustered and then did a simple random sample of that cluster. So that's multi-stage. Technically, pure clustering would have been this. You randomly choose a cluster and then guess what? You average the entire cluster. Okay? That's technical, straightforward cluster sampling, where you randomly choose one or more of the things and then you survey or you do whatever you're doing to all of the items in the chosen clusters. Okay. So that would have meant that if you happen to choose cluster 3, you would have averaged that whole entire cluster and gotten all the average of all this. Okay. Advantage. It's quick and easy. Reasonably pretty easy to do. Disadvantage. Okay. I'm going to give you an example to see if you can figure out what the disadvantage would be. Toledo High School, you're all in your first period classes. So the first period classes are your clusters. I'm going to put all the teachers' names into a big bag, and I'm going to pull out a class, a first period class, and you know what I'm going to do? I'm going to ask every student, all the students in that cluster, what their favorite elective is. Ah. So there's a potential problem that cluster could be just like athletics, or could have been Coach Jones, those people registered to Coach Jones or whatever, and those are athletic people, or maybe they're band people. Okay? And so then you would have some bias. Okay, they would be more prone to maybe have more that like that particular elective or whatever. Okay, so that's because that cluster is not what? That one cluster is not, let's some vocabulary here, it starts with an R, representative of the whole population. So a cluster was chosen that wasn't representative of the whole population. So that's a disadvantage. You kind of have to make sure that your clusters are kind of just all random sprinkles with whatever you're doing. Okay, so the disadvantage is a cluster may not be representative of the population. Okay? So if you were going to ask the question, what's your favorite elective, you probably would not stratify by first period because of that potential problem. You might stratify by advisory. Okay, that might be a better way to stratify. So you just got to kind of, or cluster, no, yeah, cluster, sorry. Cluster by advisory. Okay. Next, we're about out of time. So I think you're going to have to tell me tomorrow, because I stopped in a different place in every class, that we are at stratified, and then we'll finish that out. Okay.